So the three of you have been working together for what? Has it been 10 years or like has it been a decade? I think so, right? Or at least two of you?
Ungefähr.
Yeah, something like this.
Yeah,
I
something
think
like
10
that.
years
Yeah,
sounds
right.
about
And
right.
Atom, this
2014.
was also 10 years ago. And then you said we're building Zed, and it's pretty clear that you have a vision for what you want to build, and you also made some really distinct technological choices. You use Rust, GPU accelerated, CRDTs, and I'm wondering like how much are these technological choices tied in with the vision for Zed? Like how much does the technology play a role?
I mean, from my perspective, the vision for Zed is just a more refined and fleshed out version of the original vision for Atom, which just fell short due to the technical choices we made, in my mind, and the level of technical maturity that I think all of us had when we started Atom. But the goal I've always had is a lightweight editor that is minimal, that I love using, that feels like a text editor, but has the power of an IDE when needed without all of the slowness in the experience and kind of heaviness in the UI, but still being powerful. And then that was like, very early what I wanted. And for it to be extensible. So, I remember using Emacs and thinking it was so cool that you could extend it, but you were sort of operating at the character level. So that was part of the original vision, and now Max has achieved that with Tree Sitter. Basically scriptability. We're not scriptable yet, but we'll get there. But when we are, we'll have access to a richer representation of the text than just looping over characters or whatever I was doing in Emacs. I mean, they probably have that now as well, right? Because Max wrote Tree Sitter.
They do.
So that's cool.
I hear.
But anyway, that was all part of the vision. And, it just didn't pan out with Atom. I mean, when Chris hired me to work on Atom, I almost didn't join because I was afraid of using web tech, that it wouldn't be able to get there. But to be honest, I don't know that whatever I had at my disposal at the time would have gotten us any better, because Rust didn't exist back then. So it would have been C, C++. I don't know. It would have been really hard to do something native at the time we created Atom. And I don't think my skills were in place on just fundamental algorithms, et cetera, that are critical to text editing. And C++ would have really slowed me down in my learning there. So I think it happened how it needed to happen. But so I don't know. We got to a certain point with Atom. It was like 2017. We'd shipped Teletype, and it felt like, okay, it's no longer our own ignorance holding us back. It really is like the platform holding us back at this point, is really how it was starting to feel. Like just the fact that in JavaScript, an array in JavaScript is, you think you have an array of objects, but you really have an array of pointers to objects. So every single time you're walking over that, you're chasing it down. You have no control over memory. There are garbage collector pauses that are just happening that you have no control over. You just look at the profile of the freaking thing. Sorry, I'm really rambling. I can pause for a second.
Was there a specific thing where you said on Atom, where you said, "Oh, I wish we would have built it with X," or was it, accumulation of paper cuts? Antonio was nodding right now with this.
I remember, speaking of, 10 years of working on this thing, one of my first projects in Atom, I don't know if you remember this, Nathan, was speeding up line layout. Basically, we were seeing line layout being very slow. And so I remember, trying rendering lines in a knife frame, right? And I remember using Canvas, measured text, and all these APIs that were I don't know, the Canvas API wasn't quite the same as the browser API, so you couldn't really measure text correctly. The iframe stuff had some other weird problem. And so it was always, I don't know, my experience in Atom always felt like bending over backwards to, try to achieve something that in principle should have been simple. lay out some lines and read, position the cursor at this spot in between these two characters. Like, it seems like fundamentally doable, and yet
it
always felt like, the tools were not at our disposal. They were very far away from what we wanted to do.
I mean, the ironic thing is that we created Electron to create Atom, but I think like Electron's, I can't imagine a worse application for Electron than a code editor. I don't know. Like, for something simpler, I think it's probably fine. The memory footprint sucks, but like it's fine. But for a code editor, you just don't have the level of control I think you need to do these things in a straightforward way at the very least. It's always some, backflip. So at some point in 2017, I was just like, I don't know. I remember sitting there like writing in Atom in my journal, like, I don't know, the evening where I'm just like, we have to start over. Like, this isn't working and we're never going to get this where we want it to go. VS Code's done an admirable job getting it as far as it's going to go, or, it'll be incremental improvements in the tech, I'm sure. But like, I just wanted more. So at that point, it was like, okay, what should we do? And, I'd been watching Rust. I'd seen some of Rafe Levine's writing about Rust. And at the time, it was like, this seems like the only viable path to like kind of overcome some of these obstacles. And it started as just, okay, what if we just write the core of this thing in Rust and we keep Electron as the presentation layer? So it was just inch by inch that we came to the technological decisions we chose. And it was really like, even after building the UI framework, giving up on Electron, we were using Pathfinder, which is like this really cool project that could do this arbitrary presentation of SVGs basically, but it was too slow. So then I'm like, okay, well, what if we do our own shaders? And then went and learned about signed distance fields. It was just like at every point, it was kind of funny. It was me not wanting to solve some more fundamental problem, but just being forced to do that by the unavailability of any other choice. Yeah.
So it sounds like it was.
And Antonio in this. Sorry, continue. Sorry,
And Antonio.
I shouldn't. It wasn't only me. I shouldn't say me, but from my perspective, it was.
Yeah. But that sounds like it was truly. I don't know what the cart and what the horse is, but it's the goal was always as fast as possible, as lightweight as possible, and you tried to get there, but you couldn't with the technology you had. And then Rust came along, and then basically you didn't say we want to build a GPU accelerated editor. You said we want to build the fastest possible editor, and then GPU acceleration was one way to do that. Is that right?
Yeah. It's like we have this hardware in the computer that rather than like negotiating with what DOM nodes are in the DOM at a given moment or all this nonsense, we could just literally be like, what color should this pixel be? Yeah. It's like, great. Okay, if we can program that hardware, right, decide what color every pixel on the screen should be in parallel, or as parallel as we possibly can, like we should probably use that if we want to be fast. Yeah. I don't know, but we came there kind of grudgingly because I didn't know how to do any of it.
Yeah. I guess it was always possible to, go down to C or whatever, or C++, as you said. But it sounds like that was an option, and I'm kind of, this is a loaded question, I guess. But
yeah,
I've been working in Rust, for, not working, but on the side, hacking Rust for the last 3 years or something. And I have, thoughts about it. It's not, it's complicated language and whatnot. But then there was when was it, 2 weeks ago, Antonio, when the guy on Hacker News said, search all occurrences in this buffer takes a second or something. And in Sublime, it's really fast, like 200 milliseconds. So and then Antonio basically, we paired, but he then wrote the code to optimize for this case of searching all the occurrences in the buffer. But the optimized code wasn't optimized code, right? It didn't use any dirty tricks or, use SIMD or whatever. It read like high level stuff, except that the assumption was different. Instead of doing it one by one, it said, I want to find all of the results. So for all of the results, blah, blah, blah. And then we build the release build and started up. And I thought, let's see how much faster this is. And it went from 1 second to 4 milliseconds. And to me, I sat there looking at this, first of all, like happy and nice that this is going to be good lunch, but 4 milliseconds, and you see that high level code, which was truly, find all matches for each match, find the bounding box, and blah, blah, blah. So again, loaded question, but what I'm trying to say is Rust, zero cost abstractions. Is this where you think the sweet spot is, where you need that high level of abstraction to build a text editor with all of the things you want, but it still gives you this performance? Like, is this a specific thing about Rust, or do you think if you had just been a better C++ programmer or C programmer or whatever, you could have done it in another language?
Yeah, I mean, I think you probably could have done it with C and C++. I don't know. I mean, Tree Sitter is written in C, right, Max?
Yeah.
So it is possible to write a complex library piece of software in C. Although I have to say, anytime I look at the C code in Tree Sitter, I scream because it's just too much for me. I don't know. I think personally, yeah, Rust is a sweet spot. If it wasn't for compile time being that slow, and that is thing that I really don't like about the language. Maybe it's our project that's too big. I don't know. But yeah, it is pretty cool that you can build on top of these abstractions and just, you can rely on them. I mean, I don't know about zero cost. I guess, every abstraction has a cost, I guess. But the thing, I don't know, with the project in general, as it's written today, I don't know, what comes to mind is, in Atom, it always felt like we didn't know where to look for in terms of performance. With this, it's we could do this and we could do that and we could improve this. Right last week, Nathan and I were discussing how to improve this abstraction, the sum tree, to perform batched insertion a lot faster. So yeah, I don't know. I'm.
And then you implemented it, right?
Yeah, it hasn't shipped yet because of the display link stuff that we were just talking about. But yeah,
right.
Yeah, I'll say we did do a lot of C++ on Atom, and we did a lot. We tried. And it worked, but it was just that we'd have to sort of. There was a very meaningful distinction, obviously, where the boundary was between the JavaScript application code and the C++ library code. And people would talk about our performance and say just do this on a background thread, just don't do it on the main thread. And we'd be okay, we can do that, but that means this whole subsystem that is involved needs to. Maybe this has gotten better with the threading APIs in JavaScript, but we would have to drop. In order to share memory, in which case we'd need to for a lot of the tasks we were trying to move to background threads, we need to drop a whole subsystem into, build JavaScript APIs around that, decide how it's going to still look like idiomatic JavaScript code, and preserve all these properties that it had from when it was written in JavaScript, and it was easy to do different things. And then we could do the actually moving this one task to the background thread, and it was such such a difference between writing JavaScript code that was scriptable and nice, pluggable, overridable, and then the C++ code that was just had the core capability to have shared memory and multi-threading.
And I don't know, Rust is designed to be multi-threaded. And I remember when I tried to learn Rust initially, this was, I think before, anyway, I tried to learn Rust and I wanted to implement this splay tree, because the splay tree was a structure that we used a lot in Atom, actually, for a time. It had its era, at least. I mean, it was actually pretty good for our needs, but it had parent pointers. It was very much a mutable structure, and I tried to build that in Rust, and I didn't have a firm. I could build that in Rust now, I think, but I think it wasn't a great thing to learn a Rust on, and the language fought me. And I'm just like, can you even build a freaking good, like, can you build anything real in this language? Like, I had serious doubts, actually. So I gave up for a while. Then I tried again. And this time around, I built a copy on write B tree. And when I built it that way, it used arcs, and that meant it was inherently like multi-threading friendly. And it was like when I followed the kind of diktats of the language in the borrow checker and did it the way Rust wanted me to do it. Oh, cool. Now we have this way of representing ropes, right? Which is the fundamental text storage structure in Zed, in a way where we can like spawn a background thread, and it's O1. It's just bumping an arc to take that to a background thread and look at a snapshot, etc. Right? And so it's just like, it's not just about getting native. I also think Rust brings to the table innovations that it's like, we can actually, the language is designed to be used the way we're using it on multiple threads and at a low level. And frankly, like, I was just a little too much of a script kiddie, I think, to do well in C++. Like, it always just annoyed me. Just like these freaking files jumping over here, all these arcane rules. And like, maybe, I don't know. Again, like, could a C++ master do what we did in Rust? Probably, but like, I wasn't gonna become that person. So yeah.
The three of you, Antonio, you just mentioned in JavaScript we didn't know where to look for performance. Max, you said, when we were using C++ or JavaScript, we had these problems of, we felt these boundaries of, if we want to make this async, we have to move the whole thing over, all of this. And you said the same thing about, Rust. You can suddenly do stuff async on a background thread. You have less restrictions. You can move freely around. And that reminds me of, you mentioned this, Nathan, but you see it in the code base, and that is, you own the whole stack, right? Like from TreeSitter, the parsing, GPUI, the GPU accelerated UI framework. There's not a lot of third-party dependencies in the code base. I think except libraries and whatnot, but not big building blocks. Everything is built basically in-house using small building blocks, except for collaboration, right? But how important is that for you? We own the full stack. We own it top to bottom. We understand it top to bottom. Is that a conscious choice, or is this, it happened by accident because Max built TreeSitter, then we did this, and now look at us, we rebuilt the whole thing?
I have a lot of opinions, but I talk a lot, so let you two start.
Yeah, I'd be okay with you starting, Nathan, or Max. Yeah,
okay. Max, do you have thoughts on it?
I don't know. I think it has trade-offs, but I think so far it's been pretty nice to be able to just decide how we want things to work. Like we, I don't know, just like right now, like we want to have language extensions that use WASM, and like TreeSitter didn't have that, but like we added that, and we want to render. I don't know, a million things. Like we want to control, we don't want to be beholden to some UI framework that like may not render text like exactly the way we want, because we're a text editor and that like matters a lot. And so like we can go change that. There's very low, doesn't feel like anything is sort of off limits. Yeah.
One thing I'll say, this was very informed by an experience earlier in my career of jQuery. jQuery was like the hot thing, and I learned jQuery. I remember Yehuda coming to Pivotal and presenting on jQuery, and I was like, this is so cool. I was like blown away by it. jQuery 4 just came out, right?
Yeah.
And so early on, like all the Atom code, believe it or not, was jQuery. And the funny thing was, though, having learned jQuery, because everybody told me like, the reason you use jQuery is it abstracts over all the differences in the browser APIs, etc. And I never really questioned that. And then I remember the day that I just sat down and read the freaking DOM APIs. And I was like, this is actually fine. Maybe there were some missing features or something. Sorry, I don't want to shit on jQuery. I think it has its role, right? Like, and it could have changed since then. But like what I came away with was more just like, if I don't have an abstraction that's like nailing almost 100% of my needs, then I might want to just not have that abstraction and go to the level below, understand the level below it fully, and then like do what I need to do. And so like that was kind of GPUI of like there were some UI frameworks in flight in like whenever it was that we started on GPUI. That was like 2019. But none of them did what I knew we would need to do. And I didn't understand them. But what I knew I could come to understand quite easily was just like, what are the fundamental primitives that we're going to be relying on? The language, the graphics framework. Like I knew we could learn those things. And I knew we'd written a lot of code. And so it's like, if I can build a system that I can understand and learn from, then I know that I can do what we need to do if it's fundamentally possible on the underlying system. And so really it was just like, at least for GPUI, it was just like a survival strategy of like, yeah, I need to understand this, and the best way to understand it is to build it.
What are the downsides of that? Max, you said
Takes forever. Yeah, it's slow. And I mean,
yeah.
Yeah.
It's also tricky to onboard people, I guess. You know, you're not using the X framework out there that everybody knows. You have to teach this, this code base from scratch, like 300,000 lines of code. So I think that is a downside. But the cool thing is that I don't know. You have that is a downside, but at the same time, there's somebody else who has written that code that can explain it to the new person, and I don't know. It might be slower, but again, you're retaining control. So yeah, I mean that is a downside, though. Yeah.
But I think it accumulates. Like the advantages accumulate and the downsides depreciate. I guess like someone just built another app on GPUI, so like cool, now we have another stakeholder. Like so now the cost of having owned it, we're gonna gradually write off over time, and the cost and the upsides of owning it are gonna start to kick in.
So that that reminds me of sometimes people say, I only build it once and then I never have to touch it again. And the opposite of that is, well, you can predict the future, worse is better, whatsoever. I think I was always or am tending towards the latter camp in a lot of things, but it's context dependent. And what I'm trying to ask is, you said it's slower to build it all yourself. At the same time, it has a ring of, build it once and do it right. For our use case, only the perfect abstraction for what we want to do. But at the same time, there's still this sense of urgency that you all have, right? I mean, I joined now, it's 4 weeks, but I do feel like we're moving fast, and we've got so much to do. So how do you balance this? How do you have this huge vision for what you want to build? How do you balance this with then saying, I'm going to write shaders, I'm going to perfect how we render, drop shadows or whatever?
Build what you need, only what you need, no more, no less, and build that as well as you can within reason. And then when it turns out to not be quite what you needed, be willing to revisit it after you've learned. But I think if you're laying down every brushstroke with intentionality and care, but you're not wasting time speculating about what you might need, then for me, that's always worked out. Sometimes it takes a while though. Yeah, go ahead.
I would add on top of that it's like a gradient. It's not like everything needs to be built, perfectly, I feel, or at least that's how I feel about much of the code we write is like, if we're writing stuff in GPUI, well, like the whole app depends on GPUI, like that better be like perfect. Or, another example is the sum tree. It's this data structure that's used everywhere in the code base. Like that, we really want to nail that abstraction because it has to be fast, work perfectly, so that we can build on top of it, right? And that is reflected, I think, also on the testing that we do on those things. Like, the sum tree is randomized tested because we want to make sure that all those edge cases work perfectly. Now, as you move towards the edge, that performance improvement that you alluded to, Torsten, right? Like, I feel like we didn't spend 3 hours, gold plating it, right? It was like, okay, whatever gets the job done, it's pretty much at the edge. I mean, we should feel good about the code. We should always strive to write as best code as we can, but we don't need to gold plate it, like I said. So I think it's a gradient, right? And so the more core something is, I think the more it deserves thought and quality.
And my favorite code to write is the code I've earned myself the right to write. Well, that's a lot of homophones. Where I've contended with the system for a long time, and I'm like, okay, like that. Basically, GPUI 2. Like, I had so much fun writing it that I almost felt like guilty about it. But it's like, okay, but I have earned the right to write this code because I wrote the first version, I lived with it, I pushed it forward, I made the compromises when I needed to make them to make things right. But now is the moment where we can make this better. And it makes sense to make this better. And I'm informed. I think a lot of times when people talk about like rewriting, it's like, oh, if you're rewriting something someone else wrote, like be doubly suspicious of yourself. Because but if you wrote it and you've lived with it and you've put in the work, and then I don't know. So that's also something to be said, is like, I don't know. Don't let perfectionism, I guess, get in the way of learning. Like,
but that to me sounds like if I were to take the three of you, and I mean, I don't know what to throw at you that you couldn't build, but say a new domain, you have to build. Yeah. I don't know what. I can't make something up right now. I don't know, like a pit controller for an airplane. I don't know, airplane software. Something like this. So basically, you don't know the domain, and you don't know yet how you're going to build it, and you don't yet know which parts you're going to need. Is this way you would say different approach? Because in the editor, we have a strong vision for what we want. We build a few before, so now we know which parts count. We know beforehand GPUI is going to be important, so let's take our time with it and gold plate it, as Antonio said.
Yeah, I mean, I don't know if a nuclear reactor is a good example, but I do feel like if it was our first code editor, we did worse is better editor. Yeah. I mean, and not like it was like intentionally like, bad, but like we took the kind of quicker, dirtier approach once, and then kind of identified the things that were real pain points to have to like build on top of in their sort of worse is better form. So, but I do think if like for some reason Antonio and me and Nathan were like had to build like a
choose something less mission critical, maybe.
I don't know,
that's like what we want to work on,
like online, like a Shopify clone or something. Like we would probably like do like have a different mindset about it, where we didn't know which pieces needed to be like, really highly honed.
But yeah, I mean, if I were building a nuclear reactor control system, I would use a Byzantine fault tolerant consensus algorithm and pit 3 teams against one another to compromise each other's security, and then make them come to consensus on all of it. But I don't know how to do that. Anyway,
there was like another example, I think, less mission critical than a nuclear reactor, but where we didn't know the data structure and we kind of took the time to learn it. It wasn't always that the structure powering the buffers in Atom and in Zed today was a CRDT. And so I think there was a research period there where like Nathan and I read, I forget how many papers, like a lot of them. And, the approach we're using right now with the CRDT, I mean, we still rewrote it 2 or 3 times, but the approach is more or less the same. So I also think there's a part of it that comes with experience. I don't know. I feel like you tend to develop a sense of what you need to spend time on and what is more frivolous, more less important. Now, That said, we did rewrite the CRDT 2 or 3 times, but the research part, I think, was important. I don't know.
But the funny thing is, right, in the Atom that shipped, the buffer was an array of lines, a JavaScript array of strings. And in Zed, it's a multi-thread friendly, snapshotable, copy on write B tree that indexes, everything you can imagine wanting, or everything we've needed, which is like, row, column, and I don't remember what else do we index in there. We index a bunch of different things.
UTF, code points.
There you go. Yep.
Yeah.
But so we did worse is better. But yeah, starting over, would it be an array of lines again? Probably not, because it's like, okay, look at the time bounds on that, and like put a little more thought into it. But that again, like I learned that by like doing worse is better, and then having it be really slow or problematic in edge cases, right? That end up mattering.
So, what are the most gold-plated parts of Zed?
I mean, GPUI is pretty gold-plated, I think, because we just rewrote the whole freaking thing.
I think there's kind of like what's in the editor crate, where there's sort of the stack of different transforms that convert the raw text of the buffer into the kind of lines that you see on screen, like that expand the tabs and do the soft wrapping and insert the block decorations and handle folds and stuff. All those layers have this kind of uniform strategy where it's randomized tested with property testing. And so I think they're pretty gold plated. And the multi-buffer too, where we sort of weave together the different excerpts of different buffers into one thing.
I would call them,
Go ahead.
I just wanted to suggest like an alternative substance for that part of the code base. I would say it was kind of coated in blood.
Blood plated.
The buffer, you mean? The editor, or the multi?
Yeah. It's like
tests.
randomized tests where you're like, spend literally the entire day in 2021, many days in a row, just like debugging failures in these randomized tests that would find some weird edge case of this ornate. I mean, I don't say it's ornate, but it's complicated. Stacking of different layers of transformation required to present things on screen. And so it's just like, elbow grease, right? Like find the edge cases and then figure out why they're happening by reducing the log, which for a long time just happened manually. Yeah.
How did you feel during this when one of these bugs then popped up? Did you have moments of panic where you go, property testing threw a bug in our face and now, maybe this whole thing doesn't work? Like we forgot about this edge case. Panic? Or was it, well, it's just another thing to polish down, and if not, we rewrite this?
Never panic. That's the rule. Randomized tests, never panic. I don't know. I think I have a lot of faith in our capability as engineers. I don't know. I really do. And I think, maybe it might be that we have to rewrite the whole thing, and the randomized test is like telling us that. But it's fine. We just learned something. Back to the drawing board and redo it.
But what's scary is just like, how long is this going to take? And I think Lee, our seed investor, was also asking us that at certain times. But he stuck with us, and was patient because like it took a while. But it's like that piece was like, okay, like we're writing this in Rust. If we F this up, like the program is panicking, right? Like, goodbye, poof. It's not just like a stack trace gets thrown in the corner of the editor or something, like it's done. And so we knew how hard it was to get those layers right, and we knew that there was no other choice but to get them right. But yeah, I remember, Antonio, working on soft wraps and that problem we came up against where we realized the primitive we needed was this ability to like represent a patch, right? Yeah, and then to be able to compose these patches together, that was one moment where I was sweating a bit. I'm like, are we gonna freaking figure this out? And then Antonio figured it out. Yeah.
Yeah. But yeah, like, I don't know. Yeah, I would say like powering it all, in terms of, gold plating is, again, the sum tree. But even that is like, I'm sure if we, I don't know.
If we were to rewrite it.
Yeah, if we could rewrite, there are some ideas on how to make it better, So, I don't know. I think...
Like sometimes I think of, like we were talking the other night about how dope it would be, and you applied some of the ideas we talked about. But like, ultimately all these layers, like to be able to kind of construct them in a more streaming friendly ways. And you did one optimization, which is going to land on preview next week, I guess.
I need to open the PR for it still, because
to like enable more streaming input, so people don't get like zero feedback when they open a big file, but they start actually loading things in more efficiently. So does that necessitate a rewrite? Maybe not. I don't know.
It's quite interesting how often this idea of rewriting or doing it again comes up. Like we talked about this the last time, right? And it's this learning continuously. It's not, learning and then fixing something and patching something, but it's more often this, we learned something, so now let's redo it with that learning in mind versus just putting a Band-Aid on. Like it came up multiple times and last time too. And you see it in the product. You see, when I talk to you, Antonio, and you're like, before we did it like this, so now we do it like this. And even yesterday, we basically rewrote that IME, handler, because Antonio was like, we can't leave it like this. We don't want another person to fall into this rabbit hole. So let's, put a bridge on top of it.
Nice. That's good to hear. Hadn't heard about that.
So, I don't know if that makes sense, but my last question is, again, this might not make sense, but for a lot of software, say SaaS enterprise, whatever, what you said, like Shopify, right? I think most users, they do not care what technology is used as long as it works for them. And I wonder, and this is my question to you, is do you think this is different with developer tools / editors where somehow the technology used shines more through, or the users care more about it, or no?
Well, I do think it affects the type of contributions we can get. I think going back to because our users, so many of them are people who would be prepared to contribute something or other to the code base to fulfill their own needs. I think it's important that it's like easy to contribute to Zed. So if we had going back to like written it all in C++, I think that there would be a lot of people who would like want to change something about Zed, but would not be as prepared to make the change themselves. Whereas I feel like just from the contributions that we've gotten so far since going open source a few weeks ago, it's a lot. And I think people like the fact that it's written in Rust, like makes it, I think it makes it easy for people to both like, it's approachable. People can like build, they don't have to go learn how to use CMake or whatever to build the project, or JIP. They could just use Cargo. But it also like imposes like the fact that the compiler has this, all this strictness to it, like allows us as the receiving end of those contributions to often be like merge it with confidence. So I think it's really helpful.
Yeah, Rust is an absolutely beautiful tool. It's not perfect, but I love it. But yeah, does it matter to the people? I mean, I think people want a fast editor at the end of the day. We could write it in, what is it, brainfuck? Yes. They wouldn't care. I mean, but the contribution angle is super valid. Yeah. Sorry, Antonio, go ahead.
Yeah, but still, like to talk about the performance, I just think like we are forced to do things a certain way because of performance. Like, why do we have this GPU accelerated UI framework? It's because the performance needs to be at a certain level. Like, we want our frames to be below 3 milliseconds. We could rasterize everything on the CPU, and we could have used something that did that. But like, no, to some extent, like we're positioning ourselves to be like a performance editor because we want a performance editor. I want a performance editor. And so, the choice is almost like, we have no choice almost, I feel like.
There's Zig now, and like, I don't know a lot about Zig yet. I haven't had time, honestly, to like learn about it, but people I respect are excited about it. It seems like it shares some of the same goals in terms of the output as Rust. I'm unclear like what it's sacrificing in terms of safety, etc., or how they handle those things. There may be pragmatic workarounds that are sort of not as strict as Rust, but in practice work, etc. So like, I don't know. I'm intrigued by that. I'm intrigued, but then there's a lot to be said for like monoglottism, if that makes sense, of just like the servers in Rust, the front ends in Rust. But I don't know if I could get like 99% of the benefits of Rust with like 1/10 of the compile time or something. Okay. Like, yeah. Anyway,
Yeah.
I don't know. Sorry. Let's
What
keep
I
it
can tell
Rust
you-
for now, just to be clear. But like, I just wanted to talk about some perspective, I guess, on my attitude on the stack, the tech stack. Yeah.
I can tell you about Zig that a person on Discord was saying they're writing an editor in Zig, but the perfect name for a text editor in Zig is already taken, and that is Zed. So,
Sorry.
yeah. Cool. I don't have anything else. This is all I wanted to talk about today.
Man, you're really good at this, Torsten.
It's this is fun for me.